Following on from the previous video, we've seen that whenever you get given this series, if this p here is greater than 1, you know that the whole series will converge. So now we're going to try and prove for the case of p being greater than 1. We will tackle this another time, but for this one here, we're going to show that when p is greater than 1, this series will converge. So follow our normal routine. So our normal routine for the case of p being greater than 1, the first thing we would do is check that the limit of this thing here will be 0 as n moves from 1 to infinity. So as n moves from 1 to infinity, n is going to get bigger and bigger and bigger, meaning the denominator will get bigger and bigger and bigger. When you have 1 divided by something that keeps on getting bigger and bigger, then the limit will eventually be 0. So this has been satisfied. If the limit is anything other than 0, let's say 3, then you know this is going to diverge, because you're going to keep on adding 3, adding 3, adding 3 as n moves from 1 to infinity. So we know we've done our check now. So now we would compare this to this integral. So we would now, once we've done our check, we would now use that theorem where it says that if the integral diverge, then this thing will also diverge. If the integral converge, then this thing here will converge. So now well, in order for us to apply that theorem, we need to check these three. So is this thing going to be continuous in the domain from 1 to infinity? Well, you can see that it will be continuous. Is it always going to be positive? Well, in the case of p being greater than 1, it will always be positive. Is it always decreasing? Well, the denominator will just keep on getting bigger and bigger and bigger. So yes, it is gonna, the whole thing will always be decreasing. So now that all three have been satisfied, we can now apply that theorem where it says that if this thing here diverge, then this will also diverge. If this thing here converge, then this thing here will converge. So now it boils down to us trying to determine whether or not this thing will converge or if this thing will diverge for the case of p being greater than 1. So now it's just a matter of us integrating this. So let's try and integrate this. So to integrate this, let's integrate it from rather than integrating it from 1 to infinity, we are going to integrate it from 1 to b, and then later on we will allow b to head towards infinity. So let's just integrate it from 1 to an arbitrary point b. So now let's try and integrate this. So rewrite this as this. So now integrate it from 1 to b. So if you integrate this, it's going to be 1 notch higher than this. So this is to the power minus b. It's going to be 1 notch higher, and then it's going to be 1 over this thing here, which is this thing here. Well, integrate this, it will give you this. Okay, so it will give you this whole thing here. So now let me think. Now rewrite this as minus p minus 1, because minus p, and then this will be positive 1. So minus p positive 1. So rewrite this as this, and then you can, because you've got minus whatever, then this thing here will become 1 over x to the power whatever in there. So that's this thing here. Okay, so tidy this thing up. That will then give you this, and then let me think. And then this here is a constant. Once you hang on, let me think. Once you set this problem here, 1 over x to the power of p, and then this is this is, what was it, n. Bear with me, n, and then n equals 1. This is infinity. The minute you set this p here, let's say you set p to 2, say. If you set p to 2, then the minute you set p to 2, then p is fixed. P is fixed. It is the n that's moving about. In our case, it is the x that's moving about. So the minute you set the problem, p is really fixed. So this whole thing here is a constant. It is the x that's moving about. It is the x that's moving about. So so this is a constant. Because it's a constant, you can actually take it out. So it's here, and then now it's just a matter of you putting this into the x here, and then you putting the 1 into here. So that will then give you this. Okay. I will continue in the next video.